Okay, now before we can choose the appropriate statistical method, we need to organize data. So we're going to look at the measurement of scales or levels, and there are different levels of measurements. All data, all data measurements are taken on one of four major scales. And here are the scales: nominal, ordinal, interval, and ratio. And we're going to start with the one that offers us not much, and then move on to the strongest, which is ratio. So nominal scales categorize data but do not rank them. And as the name suggests, nominal, only the name here makes sense. For example, if you have, let's say, three different mutual funds: an equity fund, fixed income, and money market funds. So, 1, 2, and 3. Now, although we just numbered them, but these numbers doesn't show rank, meaning I don't know if equity fund is better than fixed income or fixed income is better than money market. I also don't know anything about the distance between these funds. For example, I can't go like equity fund plus fixed income equals money market funds, right? 1 plus 2 equals 3. Now, ordinal scales solves the problem of ranking. So ordinal scales sort data into categories that are ordered with respect to some characteristics. A good example for ordinal scales would be rating agencies that help in ratings for mutual funds. So let's say we have three funds: fund A, fund B, and C. And let's say fund A has 1 star, fund B has 2 stars, and fund A has 3 stars. I know they don't look like stars that much, but you get the point. So in this case, the more stars, the better the fund. So if that's the scale, I can clearly see that fund A is better than fund B, and fund B is better than fund C. So the ranking problem is solved. But still, I don't know anything about the distance between each fund, meaning I know that fund A is better than fund B and B better than C, but what is the difference? How much better? So although it is ordered, but I don't know anything about the distance between each fund. Now, interval scales solves the problems of ranking and the distance. Interval scales provide not only ranking but also assurance that the difference between scale values are equal. And a good example of intervals, a popular example of interval scales, is temperature. Let's say I have 2 degrees centigrade, 3 degrees centigrade, and 4 degrees centigrade. Now I can clearly see the rank. I understand that 3 degrees is hotter than 2 and 4 is hotter than 3. So no problem with the ranking, and also the distance, the difference between scale values are equal. The distance between 2 degrees centigrade and 3 is the same distance as 3 and 4. It is 1 degrees. But there's still 2 problems here. Number one is that we do not have a true 0 point, meaning that let's say I have 0 degrees centigrade. Well, 0 degrees centigrade doesn't mean no temperature. It's not the absence of temperature. It's just 0 degrees, right? And also, when we say the difference between 0 degrees and 2 degrees centigrade, well, that doesn't mean 2 degrees centigrade is twice as hot as 0 degrees, right? So no true 0 point and no ratio system. And the strongest scale, ratio scale, solves all of these problems. they all have ratio scales. They all have all the characteristics of interval measurement scales, as well as a true 0 point. And a good example for this one would be, money, meaning that if you have zero money, that means you have no money. If your money is, positive, that means, you have money. And if your money is negative, that means you owe money. So we have a true 0 point. We know the distance between each, observation, and it's equal. And also, if you have, let's say, you have $5 and $10, right? $10 is obviously is clearly twice as much as the $5, right? So there you have it. Ratio scales takes care of all the problems. Okay, let's do one example to make sure we understand different levels of measurement. State the scale of measurement for each of the following. First one is credit rating for bond issues. Now, when we were talking about different levels of measurement, we did use one example regarding ratings for mutual funds. Now, this time it's rating for bond issues. The same thing, still ordinal scale. And just so you know, when it comes to ratings for bond issues, they are ordered with respect to the expected probability of default. So we are talking about the bond issuer's ability to pay whatever they promise to pay. So that's how they are ordered, meaning the bond with the highest rating has the lowest expected probability of default. For example, Standard & Poor's rating agency, they assign letters like the best bond would be triple A, and then double A plus, on, and then triple B plus, on and on. So again, here it's very clear that the order is very clear, the rank is clear. I can understand that triple A rating is better than triple B plus, and when I say better, I mean it has a lower expected probability of default compared to triple B plus. But still, I don't know anything about the distance between the ratings, so that makes it an ordinal scale. Next one is cash dividends per share. I think this one is rather obvious. We're talking about money, and when we're talking about money, it is ratio scales. And since dividends is the cash distributed by the company, we could have zero cash dividends. So we have a true zero value as well. Moving on to the hedge fund classification types. So here, different types, group hedge funds with similar investment strategies together, and they can only be identified by the name we give them. And we don't know which one is better than the other, so that makes this one a nominal scale. And the last one would be bond maturity in years. And here we could have bonds that mature in less than a week sometimes, which is practically zero, or we could have perpetual bonds that is like never ending. And also, if I have a bond that, let's say, that matures in 5 years, and then I have a bond that matures in 10 years, I can clearly say that the bond with the 10-year maturity is twice as long as the bond with the 5-year maturity, which makes it a ratio scale.